Hi, in this video we're going to learn how to simplify a rational expression which is involving the case of a negative 1 factor. At the end of the video, you should be able to simplify a rational expression that involves a negative 1 factor. For review, there are two possibilities when you do simplifying rational expressions. The first case is just the direct dividing out the common factors, which is simple cancellation. Or it may be you need to factor the numerator and the denominator and then perform the dividing out the common factors or cancelling the common factors from the numerator and denominator. Let's have the example of the case of a negative 1 factor. Let's say simplify xz minus 4z all over z squared times 4 minus x. First things first, factor the expressions that are not already factored. In this case, it's actually the numerator. We need to factor out z. So what is left in the parentheses after factoring out z is x minus 4. What you need to notice is that we cannot cancel this because they have different signs. This is the case where we can actually extract the negative 1 in x minus 4. Now, if we are going to extract negative 1, meaning to say a positive number is actually a negative times negative, and then 4 is actually negative 1, negative 4 can be negative 1 times positive 4. So if I factor out negative 1, here's how it looks. The x changes sign and also the 4. If we are going to multiply back the negative 1 here, negative 1 times negative x is positive x. Negative 1 times positive 4 is negative 4. Why are we doing this? Well, now it's very clear that we can cancel your negative x plus 4. Besides from negative x plus 4, we can also cancel z. Cancel 1z here, cancel 1z. There's 1z left in the denominator. The whole negative x plus 4 cancels out. On the numerator, you have a negative 1. So negative 1 over z. That's going to be your final answer, the simplified form of the given rational expression. Okay, let's have another example. Simplify x squared plus x minus 6 all over 6x squared minus 3x cubed. What we can do first is factor the expressions that are not already factored. Actually, both needs to be factored. On top, what are factors of 6 that has a difference of 1? Actually, 3 and 2. And therefore, to get positive 1, 3 is positive, 2 is negative. Below, you are going to have factor out 3x squared. 3 and then x squared was factored out below. The x squared should be in front. And then what is left after factoring out 3x squared, you have negative x plus 2. Taking out 3 from here, you have 2. Taking out x squared, so you only have 2. Here, you factor out 3, and then x squared, you only have a negative x. On top, as I was saying, 6 has a factor of 3 times 2. If it's negative, 1 is negative. How do we know which one is negative? If you add, you should have a positive 1. So 3 is positive, 2 is negative. As you can see, we cannot cancel x minus 2. Again, we are going to do factoring out a negative 1 or extract the negative 1 in x minus 2. You could actually extract the negative 1 here, but either way works. So if you're going to extract negative 1 on the numerator, this x becomes negative, 2 becomes positive, and we have a negative 1 in front. And now it's switched again. So if you're going to check, negative 1 times negative x is positive x, negative 1 times 2 is negative 2. It gives you back the value. We are doing the factoring or extracting negative 1 for the reason that we can cancel now your negative x plus 2 on your both numerator and denominator. And now that's your answer. You could actually multiply negative 1 on x plus 3. Actually, negative 1 was extracted from x minus 2. You could actually multiply or perform distributive property, or the other way is saying that is expand. Expand means negative 1 is going to be distributed to x plus 3. So you have negative x minus 3 all over 3x squared. And this is going to be the last example. Simplify x squared plus 2x minus 8 all over negative x squared minus 4x. Perform or factor the expressions that are not already factored. Actually, both numerators and denominators needs to be factored. On top, you have negative 8 has a factor of 4 times 2, which is negative. Since 8 is negative, it should be 4 is positive, 2 is negative, so that 4 minus 2 gives you a positive 2. Below, you can factor actually negative x. Let's see. Actually positive x. So you have x minus 2, x plus 4 in your numerator. Below, I just factored out x. So after taking out or factoring out x here, you have negative x. Factoring out x here, you have negative 4. This does not factor, so what do? We actually extract negative 1 in x plus 4, or you could actually extract negative 1 here. Either way works. If you extract negative 1 from the negative x minus 4, you have a negative 1 here, and this becomes x plus 4. Since we are doing this one, taking out negative 1 from this x plus 4, you have a negative 1 in front, x becomes negative, 4 becomes negative. To explain, we are doing that because we are trying to cancel out negative x and negative 4 to show that it will work, because if you multiply it back, negative 1 times negative x is positive x, negative 1 times negative 4 is positive 4. The value is the same, we just factored it out to match the factors from numerator to denominator. And now we can clearly cancel the common binomial factor, which is the negative x minus 4. And you could also multiply negative 1, perform distributive property, or expand the expression. So you have negative x plus 2 all over x. And that's it. You should have learned how to simplify rational expression that involves a negative 1 factor. If you need to review, you can watch the video again. Thank you.